Okay, so this is what the total syllabus is. Then here, first I need to divide this one into three types. So one is electrostatics. Electrostatics. Second one, in this part we are going to study about the Gauss law and other parts. The next one is magnetostatics. Magnetostatics. Then third part is electrodynamics. Electrodynamics. So this includes, so this electrodynamics includes charge particle as well as charge particle uh, as well as variation of fields with variation of electric field and magnetic field as well as electromagnetic waves. Okay, so here we are going to study almost advanced concepts. So these are basic rules. And second PhD when BSc level the syllabus is up to more than 50-60% that we need to study. Okay, so if I start with the basic revision of electrostatics, how do you define the electrostatics? First, let me start with electrostatics. Electrostatics. So here, how to define this electrostatics means? It's a study of electrostatics is nothing but it's a study of the charges which are at rest. So it's a study of charges or behavior of the charges, behavior of charges in rest in a static form. Static form means where charge will be at a charge will be at rest. Okay, charge will be at rest in this part. And mainly, if I consider this charge, so charge is given as Q. So Q may be positive, negative, or zero. So zero is defined as a neutral one, neutral charge. Okay. Then remember that charge is always quantized. Charge is also quantized quantity. So, therefore, charge is generally represented as, that is in terms of electron charge. Electron charge, that is in terms of Coulomb. Okay. Therefore, that is given as Q is defined as is the unit of C. So Q is generally given as a value of 1.6 into 10 to the power of minus 19 Coulomb, as if it is treated as a positive electron. So if it is negative, then it will be given as minus sign. Okay. Then this will be for electron. Right. So basically, according to Coulomb's law, we define the interaction between the charges. Like poles will attract and so like poles will repel and like poles attract each other. Therefore, according to Coulomb's law, so Coulomb's law of electrostatic interaction. So that is Coulomb's law. So according to Coulomb's law, so if there is a charge, one charge here, and another one charge is here, then if there is a distance between those two charges is this r. So as if they are same charges, if they are if they are positive charges only, then there will be a repulsive force on Q2. Q2 will be repelled by first force, correct? So that is the force acted on the second one by first one, and this will be equal to force acted by the first one on second. So that is for on first one due to second one. So these two are opposite but opposite forces because they are going to repel. If they are opposite charges, if there is minus plus Q1 and minus Q2, then they will be attracted. They will be attracted. So this will be attracted by negative charge, this will be attracted by positive charge. So we generally call this one as the force due to the force on second one due to the first one, and this is due to force on the first one due to the second one. These are vector quantities. Therefore, this generally the force of interaction between the two charges is given by, as it is a vector quantity, it is given by 1 by 4 pi epsilon naught. It is q1 q2 divided by r21 square into r21 vector cap. So this is a, as it is a vector, I am representing this as a vector quantity because this is a unit vector. It is unit vector, and moreover it is also a central force, means always it acts between the centers of those charges. So this is the force will be along the line joining of those two charges. So its meaning is that as it is a vector, force between force between charges, force between charges acts along the line and line joining those two charges. Line joining those two charges. Those two charges. Okay. See, this is of the Coulomb's law. If I represent the same force in terms of vector, that is given as force is vector, that is equal to 1 by 4 pi epsilon naught, that is q1 q2 divided by r cube r21 cube into r vector, that is 2. So this is in terms of vector notation. So this is in, so r vector, so position vector, or position vector, position vector. Okay, if it is here is the r vector, then it will be r cube. If it's the r cap, only unit vector, then it will be r square. Okay, so this is what the equation to define the force or interaction between two charges according to the Coulomb's law. Similarly, to define the electric field also. What do you mean by electric field here? So electric field. So electric field is actually given by, it's a region around the charge where its effect is felt, whether it is a repulsive if any on the other unit charge ಅನ್ನು ತಗೊಂಬಂದ್ರಿ. So if there is a charge here, if you bring any positive unit charge, let me call this as a test charge or unit charge, test charge. Okay, if you bring a test charge in the region around the charge where it's positive or whether it's attractive or repulsive, um, that forces or interactions will be felt, then that region around the charge is called as electric field. This is the field. Okay. Therefore, generally that electric field is given by E vector is equal to, that is force divided by unit charge Q. Therefore, that is given by 1 by 4 pi epsilon naught, which is Q divided by R square into R vector. So this is the R is the distance where you want to take its field. Okay. So this is defined as a electric field. And similarly, we are going to define electric potential also. That is, electric potential is given by electric potential. Electric potential. So electric potential is the strength of the charge. Strength of the charge where, so this is Q is the charge ಇತ್ತಂದ್ರೆ ಈ ಸುತ್ತಲೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅದು ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಒಳಗಡೆ ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಎಷ್ಟು ಅದ ಚೆಕ್ ಮಾಡೋದ್ರಿಂದ ಪೊಟೆನ್ಷಿಯಲ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. So if you want to calculate the potential at this point, it is nothing but it's a form of energy where if you want to bring the positive unit charge infinity infinity to the a point in the field, then that strength to bring this charge from here to here in the field is defined as a potential. That is given as potential is equal to 1 by 4 pi epsilon naught, that is Q divided by, just it is a R. Q divided by just it is R. So this is defined as electrostatic potential. So this is defined as electrostatic potential. right? So for this, the same electrostatic parts are going to define the Gauss law. So how to define the Gauss law actually? So Gauss law tells that if you want to calculate the field which is coming out of this charge, the field around the charge, let us draw a imaginary Gaussian surface. Okay. If you calculate if there are n number of charges, so this is Q1 and Q2. Okay. And Q3 is also there. So if you want to calculate the field around this one, means to just to define the field around these two charges, these all the charges, let us draw a imaginary surface. So this is imaginary closed surface around the charges. Imaginary closed surface around the charge, around the charges, around the charges. Then, then that imaginary closed surface is called as Gaussian surface. Gaussian surface. What exactly, according to the Gaussian surface, we define like this Gauss law? That is, the charge enclosed within the that is electric field coming out of the Gaussian surface. Electric field coming out of Gaussian surface. Coming out of Gaussian surface. Gaussian surface is all equal to 1 by sorry, epsilon times 1 by epsilon times 1 by epsilon times the charge enclosed within the surface. Enclosed within the surface. See, remember, it's also called as electric field or electric flux. Electric flux. So electric flux is the ಯಾವುದೇ vector quantity. If any vector quantity which is coming out of a closed surface is called as a flux. If it is a positive charge, then positive charge in the electric field lines ಯಾವತ್ತೂ ಏನಿರ್ತವೆ? They will be outward from this. So if you want to calculate the field which is coming out of this Gaussian surface around this charge, ಈ ಕ್ಲೋಸ್ ಸರ್ಫೇಸ್ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಹೊರಗಡೆ ಬರ್ತದಪ್ಪ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದ್ರಿಂದ that is given by electric field coming out of the closed surface. It is closed surface. This is defined mathematically, that is electric field which is coming out of the closed surface is always equal to charge enclosed divided by epsilon naught. That is, this charge enclosed is nothing but net charge within the surface. Net charge within the surface. Now inside the closed Gaussian surface. So this is given by Gauss law. What it takes, this ds is nothing but a area of small area of Gaussian surface. Small area of Gaussian surface. Gaussian surface. So if you want to calculate the electric field due to the point charge, that is electric field due to point charge. Field due to point charge. We are going to define point charge. We define that. Let us call this is Q charge. Then there is a Gaussian surface around this one. That Gaussian surface will be always closed, as this is a spherical Gaussian surface. Spherical Gaussian surface. Okay, surface. Then let us call this is the from Q to at the surface distance R. And how to define the closed surface area? That is integral over electric field dot ds vector. Both are vector quantities. This is defined as actually electric flux. Electric flux. So the quantity which is coming out of the closed surface is called as flux. Quantity coming out of closed surface. Closed surface. is defined as, that is flux. Therefore, electric flux is given by 1 by epsilon naught times charge enclosed within that. So how much charge it is enclosed within the surface? That is Q. The charge enclosed within the surface is given by Q. Therefore, surface integral closed surface integral E ds equal to, that is Q divided by epsilon naught. So how do you calculate the closed? So you need to calculate the electric field here. So keep this electric field here only. E dot. What is the areal integration? The ds. This is the areal element. So for this spherical surface, areal element is given by, for spherical surface for spherical surface, areal element is given by, areal element is given by, that is ds is equal to r square sin theta d theta d phi. Okay. So if you want to calculate the total area of the closed spherical surface, then we are going to do that one as pi r square, because its radius is r square. Its radius is r. Therefore, E is E dot 4 pi r square, right? Then is equal to Q divided by epsilon naught. So if I want to calculate the electric field, E is equal to Q, that is Q divided by 4 pi epsilon naught into r square. So this is the electric field which is coming out of the charge at a distance r. So electric field or electric field intensity, field or electric field intensity, electric field intensity, electric field intensity. Okay, so this is what the Gauss law can be defined for. Any surface, take whatever may be the surface, then we are going to get that one electric field due to that part. Here, this ds is the area of a charge. The area of this ds is the area of Gaussian surface. Okay, the same Gauss law can be defined in the form of differential form. Gauss law in differential form. In differential form. So according to the Gaussian rule, that is, we can convert from surface integral to volume integral. You can convert that one from surface integral to volume integral. So if this is there is a vector a dot ds, then it can be converted into volume vector, that is by integrating. So let us call this the v is the vector. So areal vector to volume vector. So this, let me call this is capital A is the vector. Capital A is a vector. So this is just a vector. Okay. So this, according to the Gauss divergence law, according to according to Gauss divergence theorem, Gauss divergence theorem, divergence theorem, we can convert from areal integral to volume integral by taking, as it is double integral, here it is triple integral, that is del dot a vector is equal to, that is integral over sorry, del dot a into dv. We can rewrite this one as del dot dv into a dv. So this is called as volume element, volume element, and this is areal element, areal element. Okay. See here, we can convert from area integral to volume integral. That is from Gauss divergence theorem. We have, according to the Gauss law. So according to Gauss law, we have Gauss law in electrostatics, that is given by, that is double integral over E dot ds vector is equal to Q divided by epsilon naught. We have written. If I can convert this one into volume integral by taking its divergence. This del dot E is defined as, del dot A is defined as, this is a divergence. Therefore, I can rewrite this as triple integral over del dot E into dV volume element, that is equal to Q divided by epsilon. See, I can convert this Q in terms of the volume part, that is given by charge density rho is equal to Q divided by volume, that is dQ divided by dV. Therefore, I can rewrite that is dQ is equal to rho into dV. That if I integrate on the both the side, I get the total charge Q is equal to rho into dV. So anyway, it's a volume integral. So it's a volume integral. Therefore, I can rewrite the same equation as triple integral over del dot E, okay, into dV, that is equal to triple integral over rho into dV divided by epsilon. So both the side triple integral get cancels. I left with del dot E is equal to only rho divided by epsilon. So this is called as differential form of Gauss law. So this is differential form of Gauss law. Differential form of Gauss law. Is that clear? There is a relation between electric field and potential. Relation between electric field and electric field and electric field and potential. Electric field and potential. That is given by. See here. So for static static electric field, electric field, we have that E is equal to E will be static electric field E. Then if the electric field static ಇತ್ತು charge movement ಮಾಡಾತಿದ್ದಿಲ್ಲ ಅಂತಂದ್ರೆ static electric field, so energy will be conserved. So that electric field will be conserved. So see, and we have that force is equal to Q into E, isn't it? Because E is equal to F by Q ಬರ್ದಿವಿ, E is equal to F by Q ಬರ್ದಿವಿ ಅಂತಂದ್ರೆ then I can write F is equal to QE. We know that if F is conserved, we can rewrite that one as del cross F is equal to the curl of the force or that vector is equal to 0. If anything is conserved, then its curl will be always 0. Similarly, to have that static electric field, if they call that, if this electric field is a static one, if this E is static field, then then del cross del cross E is always equal to 0. Remember, this is very important. Okay. So if we call any electric field is static one, then its curl will be 0 because electric field will be conserved. So according to the vector according to vector calculus. So if any vector A is equal to 0 ಆಗಿತ್ತು ಅಂದ್ರೆ, then a curl of anything is 0. This is curl of anything is 0 ಆಗಿತ್ತು ಅಂದ್ರೆ, then there exists a scalar potential for a scalar term for this particular given vector. There exists a scalar gradient for the given vector. So that is given by, that is if del cross A equal to 0, then there exists A vector is equal to del cross del dot, sorry, that is del V. What is this? Just del V. V is del phi. Let me call this is del phi. Okay. Del phi. What is this phi here? So even moreover it is a minus del phi. So del phi is nothing but it's a scalar quantity. Scalar quantity. ಯಾವುದೋ ಒಂದು ವೆಕ್ಟರ್ ಇರಲಿ ಅದ್ರ ಕರ್ಲ್ ಜೀರೋ ಆಗಿತ್ತು ಅಂದ್ರೆ ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂಗ ಒಂದು ಏನೋ ಪೊಟೆನ್ಷಿಯಲ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಆ ಪೊಟೆನ್ಷಿಯಲ್ ನಾವೇನು ಬರಿತೀವಿ ಜನರಲಿ ರೈಟ್ ದಟ್ as gradient. So where A is equal to so negative gradient of that potential, scalar part. Therefore, similarly, here we have defined that electrostatics, that is del cross F is equal to, so according to the force C, del cross F is equal to 0, means this is for conservative force. Okay. Then as the force is a vector quantity, that del cross F is equal to 0, then there exists that force is equal to negative potential energy gradient that we have written. That is, we write that as minus del U antanu barithi. So this is negative gradient, negative potential energy gradient, negative potential potential energy gradient. Moreover, this potential is a scalar one, it's a scalar quantity. So phi badli ಏನು ಬರಿತೀವಿ ನಾವು v ಬರಿತೀವಿ ಅಷ್ಟೇ. Therefore, that force is given by force is equal to minus del v. It's also vector. Gradient is a vector, but v is not a vector quantity. So this is what the negative potential gradient, where this u or v is defined as u, or let me write this is u because it's a potential energy. Okay. Similarly, for electric field also we can define. Similarly, for electric field we define that one as, how do we write for the electric field? As they see, just del cross F is equal to 0 means, can I write this one F by substituting F here? The E, the del cross E into Q, that is equal to 0. Anyway, Q is a quantity, then it is going to be del cross E is equal to 0. This tells that the field is static one. Okay, static one. Similarly, as this vector is equal to 0, then there exists a gradient. For this. That electric field is actually equal to negative potential electrostatic potential gradient. Where this now phi is equal to, where this V is defined as electrostatic just a potential. So potential. For force ಗೆ electrostatic potential energy define ಮಾಡ್ತೀವಿ, here it is just electrostatic potential. Therefore, it is called as electric field is negative potential gradient. Negative just a potential gradient. Negative potential gradient. So here E is defined as electric field. Okay. And similarly, so this is what the electric field is. Now, if we have the relation, that is relation between electric field and potential is given by E is equal to minus del V. Even if we calculate this, as the potential is given by 1 by 4 pi epsilon Q divided by just its R. Where in case of electric field is given by 1 by 4 pi epsilon Q divided by R square. So if you differentiate the potential with respect to R, so that is the potential, that is del V is defined as dV divided by dr. It's a gradient. So if you calculate this one, you are going to get 1 minus 1 by 4 pi epsilon Q divided by R square. So as this electric field is given as electric field is equal to what I've got here. So if this is nothing but a negative sign of del of V, because by comparing this equation with this equation, then I can rewrite and as this is actually nothing but electric field. So the electric field is equal to minus 3 del of V. So therefore we write that is electric field is equal to negative potential gradient. So this is very important relation. Okay. Similarly, we are going to define the Poisson equation for this. Poisson equation. Okay. So Poisson equation is given by the potential. Let us call this as V is the potential. That is del square V is equal to minus rho divided by epsilon naught. So this is given as Poisson's equation. If del square V is equal to 0, V is the potential. So sometimes we write this one as or del square phi. is equal to 0, where this phi is defined as del square phi is equal to 0. So define this phi as potential, scalar potential, scalar potential. Okay. If this is equal to 0, then we call this one as Laplace equation. Laplace equation. Okay. Then even I told that. So that is what I told. Del cross E is equal to 0 itandra. We call that is static electric field. This is for static electric field. Static electric field. Or sometimes we call this one as electric field is irrotational. Electric field is irrotational. Okay. So this is what the basic concept regarding this. Okay. They have given another one term here. That is there is one problem. So can you calculate this electric field in this point? If the electric potential in a spherical polar coordinate is given by, see, question is, if the electrostatics, if the electrostatic, electrostatic potential in spherical polar coordinate is given by, spherical polar coordinate is given by, coordinate is phi of r is equal to, phi of r is equal to phi naught into e power f minus r divided by r naught. Then the charge density at the distance r equal to r naught. So then the then charge density at r equal to r naught. At the distance r equal to r naught, what is the charge density? So if they are given the electrostatic potential and they are asking difference between charge density. So what is the equation you need to apply? So according to the Poisson's equation. So according to the Poisson's equation, according to Poisson's equation, you can write that as del square phi is equal to rho divided by epsilon. Yes. Can you calculate this? This should be actually minus rho by epsilon. That's not plus. Which will be I have written minus. But here it is minus. Yes. Can you calculate rho? Quickly calculate and tell me what is rho is. In spherical polar coordinate system, that is, this is called as del square phi is called as Laplacian operator. This del square, this del square is called as Laplacian operator. Laplacian operator. How did you find this Laplacian operator in a spherical polar coordinate system? That is, del square in case of spherical polar coordinate system is given by 1 by r square. Dou by dou r of r square into dou phi divided by dou r. That is, so this is only del operator. Then if I apply on the phi, that what I am going to get, that is 1 by r square dou by dou r into r square into dou phi divided by dou r, that is equal to minus rho by epsilon. Quick, tell me what is the rho I'm going to get in this case. So this is 1 by r square. This is dou by dou r rather. Then what is about r square into what is phi? Dou phi, that is dou by dou r of, dou by dou r of phi is given by, that is phi naught into e power of minus r divided by r naught. That is equal to minus rho divided by epsilon naught. Then if you calculate what you get here, 1 by r square into dou by dou r into r square into, if you differentiate this, what I get? Phi naught into minus 1 by r naught into e power of minus r divided by r naught. That is equal to minus rho divided by epsilon naught. Then if you differentiate again with respect to r, what we are going to get here? 1 by r square. That is, here you have r square term, there is 1 e power minus r square. Then I will take phi naught into the minus 1 by r naught as a common thing. Then if I differentiate that part, once if you differentiate this r square, you get 2r into e power of minus r divided by r naught. Then next if you differentiate that another part, minus r naught r square divided by 1 by r naught into e power of minus r divided by r naught. That is equal to e minus e rho divided by epsilon. If you differentiate, if you take common here, so if you divide, if you take this one, he has asked at r equal to r naught, right? Then put r equal to r naught everywhere. What I get here, this is 1 divided by r naught cube with minus sign of phi naught, that is equal to, it is into multiplied by 2 r naught e power of minus r divided by r naught, then minus of r naught e power of minus r divided by r naught, because r naught get cancelled, so 100 by epsilon. Therefore, rho is equal to. So what I get here from this? Here I am going to get only one r. That is the minus phi naught divided by r naught square into, that is given by e power of minus r divided by r naught. That is equal to minus rho divided by epsilon. Therefore, rho is equal to, so minus minus get cancels, epsilon into phi naught divided by r naught square into e power of minus r divided by r naught. So this is the expression that we get for this result. As this is r is equal to r naught, sorry, this is becomes r naught, this becomes r naught, this becomes r naught, and this is also r naught. But I get the answer here. This rho is equal to epsilon naught phi naught divided by r naught square into 1 divided by e. So this is the answer, because e power minus 1 will get. So this is asked in CSR net. CSR network question. Similarly, as we have discussed about the electricity, things we have discussed is electrostatic field, Gauss law, force, energy, etc. Potential. Then now is electrostatic energy, electrostatic energy, electrostatic potential energy. So this is nothing but, actually it is the energy is equal to U is equal to 1 by 4 pi epsilon, that is Q divided by just Q1 Q2 divided by R. Okay. So see here. So this is different as if we have one charge on field or if you are bringing a test charge from infinity to the point in the field, then work done during this is work done to bring a a charge Q from infinite point to infinite infinite to a point in the field. Point in the field. In the field. So that is given by, that work done is defined as electrostatic potential energy. So similarly, if you look at these two equations, Q is called as 1 by 4 pi epsilon, and Q1 Q2 divided by R. What about the electrostatic field, electric potential at that point? That is given by 1 by 4 pi epsilon. That is, if the charge is here is Q1, if the second charge Q2 is brought from infinity to the point in the field. Then we define that as q. Okay, v is equal to q1 divided by just r. What about the field? Field is equal to 1 by 4 pi epsilon q1 divided by r square. This is the difference between these three. What is the relation between electrostatic energy and electrostatic potential? G is equal to, if you observe this, we are going to have q2 into v. Means if you multiply any charge to the potential, then you are going to get work. That is work done, or electrostatic potential energy, that is equal to E into V or Q into V. Generally we write that as Q into V. If you know the potential, you multiply the charge, another charge Q2, then you are going to the potential. Similarly, for continuous charge distribution, electrostatic potential energy is given by, for continuous charge distribution, for continuous charge distribution, charge distribution, electrostatic energy is given by, electrostatic energy is given by, energy is given by E is equal to epsilon divided by 2, E is equal to epsilon divided by 2 integration over E square into dV, E square into dV. This is called as energy from continuous charge distribution. Okay, so if akasmat this is E is nothing but energy, I'll define this as U on the better. So write this as U. Okay, so if this is dV ಅನ್ನೋ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ತಗೊಂಡಿವಿ ಅಂತಂದ್ರೆ ಟೋಟಲ್ ವ್ಯಾಲ್ಯೂಮ್ ತಗೊಂಡಿದ್ರೆ Q divided by volume V is equal to epsilon E square divided by E naught E square divided by 2, where this is called as energy density. Energy density is given by energy density U is equal to, or U dash or U dash, you can write this is U dash. This is equal to 1 by 2 times of epsilon into E square. So this is what the case. Is that clear? So remember that is under, that is a point I already there. So if you want to calculate the potential energy, that is potential into to charge, right? So this is what is the main thing part that we discussed discussing mainly in case of electrostatics. Okay. So now electrostatic part, part. If two charges are separated by a certain distance, if two equal and opposite charges are separated by a certain distance, is called as electric dipole. Next concept is electric dipole. Electric dipole. Electric dipole. So what do you mean by this electric dipole is, if two equal and opposite charges, two equal and opposite charges and opposite charges are separated by certain distance, are separated by certain distance, certain distance is defined as electric dipole. So how do you define the electric dipole? Charge into the distance between two charges, that is dipole. So if the charge, positive charge here is separated by a certain distance of negative charge q, and this is defined as dipole. Define this as dipole. Okay. Then generally the quantity which is measures the dipole is defined as dipole moment. Dipole moment. So what we mean by this dipole moment is, dipole moment is nothing but it is small p, it is represented the small p, that is equal to charge into distance between them, that is defined as equal to 2D and 2 means to mathematical, for only for the mathematical simplification, that is here is a minus charge, this is plus q charge. Therefore, so its direction will be always from negative to positive. So it's positive to negative. Sorry, it is always from positive to negative because field lines will move from positive to negative always. Therefore, this is the d distance between them. That is given by electric dipole moment is equal to q into 2d. Or generally we can write that as q into just d also. Sometimes we write q into d also. Okay. So potential due to the dipole. Potential due to the dipole at any point is defined as, or potential due to the dipole at any point is given by potential due to dipole at any point at a, any point at any point is given by any point. That is equal to v is equal to 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught that into p into cos theta divided by r square. So this is what the formula. So potential due to the dipole. And similarly potential due to the electric field due to the dipole is given by electric field due to dipole at any point. At any point is given by, that is E is equal to, electric field E is equal to 1 by 4 pi epsilon naught P divided by R cube. So this is given by P divided by R cube. That is 2 times of cos theta R cap plus sin theta R cap. So as it is a vector quantity, we define this one. So this is a scalar one. It's a scalar. For how to define this diagrammatically? If the two charges are separated by a certain distance, this is minus q and plus q. So these two are separated by a certain distance. If you want to calculate the electric dipole moment due to field due to these two, you have to charge the effective dipole moment to then the s charge hypothesize. So the p point where at any point is really like this. So the magnitude of the electric field is given by magnitude is given by E is equal to, that is 1 by 4 pi epsilon naught, that is P divided by R cube into, that is given by square root over 4 cos square theta plus 3 cos square theta plus 1. So as these two are perpendicular quantities, so if you look at this, so these two are perpendicular, R cap and this is the theta cap. Okay, this is the theta cap. R cap and theta cap are perpendicular to each other. If we calculate the magnitude, we are going to get actually 4 cos square theta plus sin square theta. So ಅದ್ರಾಗಿಂದ 1 cos square theta plus sin square theta ಬರೆದ್ರೆ 1 ಬರಿತೀವಿ. ಈಗ 3 cos square theta plus 1 ಬರ್ತದೆ. This is the magnitude of electric field due to a dipole moment. Okay, dipole moment. So either dipole or dipole. So let us take this is the uniform electric field. Okay, let us take this is a uniform electric field. ಇದರೊಳಗಡೆ ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ಡೈಪೋಲ್ ಅಂತ ತಂದಿಟ್ರಿ. ಸೊ ರ್ಯಾಂಡಮ್ ಪ್ಲೇ ಇದರೊಳಗಡೆ, so this is a plus q charge and this is minus q charge. So according to the rule that electric field ಯಾವ ಡೈರೆಕ್ಷನ್ ಆಗದ ಆ ಡೈರೆಕ್ಷನ್ ಆಗ ಏನಾಗ್ತೈತಿ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಮೂವ್ಮೆಂಟ್ ಮಾಡುತ್ತೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದ್ದಿದ್ದು ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗಡೆ ಮೈನಸ್ q ಚಾರ್ಜ್ ಮೂವ್ಮೆಂಟ್ ಮಾಡುತ್ತೆ. ಈಗ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗಡೆ ಒಂದು ಡೈಪೋಲ್ ತಂದಿಟ್ರಿ ಅಂದ್ರೆ ಆಟೋಮೆಟಿಕ್ ಡೈಪೋಲ್ ಮೂವ್ಮೆಂಟ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ದ ಫೋರ್ಸ್. Here the force, this force is will be calculated as force is equal to q into E in this direction. But here this force is equal to minus q into E because the charge is negative. The forces are opposite. As these two forces are acting perpendicular to the line joining. Note. So I will define here. So this is the point with respect to which these two forces are acting perpendicular to each other. Then we define that this is the theta. Then because of the application of the forces, it is going to express the torque here. Torque. The torque is given by tau vector is equal to p vector cross E vector. Here this p is defined as dipole moment. Dipole moment. So if we take this is also can be defined as p sin theta. P sin theta. Similarly, the work done in bringing, this is actually unstable point. So when it's dipole exactly ಈ ಲೊಕೇಶನ್ ಆಗಿತ್ತು ಅಂದ್ರೆ ಈ ಲೊಕೇಶನ್ ಆಗ ಏನಾದ್ರು ಮೈನಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಪ್ಲಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಇತ್ತು ಅಂದ್ರೆ ಆಟೋಮೆಟಿಕ್ಲಿ ಈ ಕಡೆ ಟರ್ನ್ ಆಗುತ್ತದೆ ಈ ಕಡೆ ಟರ್ನ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಅಂಡ್ ಇಟ್ ಆಫ್ಟರ್ ಸ್ಟೆಬಿಲಿಟಿ ಬಂದಾಗ ಏನಾಗ್ತದೆ ಇದು ಪೊಟೆನ್ಶಿಯಲ್ ಇತ್ತು ಅಂದ್ರೆ ಸ್ಟೆಬಿಲಿಟಿಗೆ ಡೈಪೋಲ್ ಹೆಂಗೆ ಓರಿಯೆಂಟ್ ಆಗಿರ್ತದೆ. ಸೊ ಪ್ಲಸ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಹಿಯರ್, ಪ್ಲಸ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಹಿಯರ್, ದೆನ್ ಮೈನಸ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಹಿಯರ್. ಕರೆಕ್ಟ್. ಸೊ ಇಲ್ಲಿಂದ ಇದಕ್ಕೇನಿದೆ ಸ್ಟೇಬಲ್ ಇದೆ. ದಿಸ್ ಇಸ್ ಸ್ಟೇಬಲ್ ಒನ್ ವೇರ್ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. therefore the work done in say rotate ಆಗತ್ತದ ಇಲ್ಲಿಂದ ಹಿಂಗೆ rotate ಆಗತ್ತದ ಅಂದ್ರೆ work done ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. So work done to rotate this dipole, work done to rotate or turn the dipole by an angle theta, turn the dipole by an angle theta, by an angle theta, that is defined as work done is equal to minus tau into d theta, minus tau into d theta, integration over minus tau into d theta. So if you calculate this, what I'm going to get here, the work done is equal to minus sine of tau is given by Pe sine theta into d theta. So I'm going to get here integration, that is work done is equal to cos theta, so minus integration of cos theta into this. So this is actually plus tau sine. So sin theta is integration minus cos theta. Then I am going to get Pe cos theta minus times of Pe minus times of P cos theta. So what do you mean by both are vectors? Therefore work done is equal to minus P vector dot E vector. So this is the work done to rotate that dipole. So this is also called as electrostatic potential energy of the dipole. Potential energy of the dipole. Energy of dipole. That is equal to U is equal to minus P vector dot E vector. Okay. Next, if the total linear force, see, tau is called as rotational force. Tau is called as rotational force. Where F is called as linear force. Linear. Okay. So main thing is here is about if the dipole is experiencing only the torque, only the torque. If total force, net force is equal to 0 ಆಗಿತ್ತು ಅಂದ್ರೆ that electric field will be always so uniform ಐತೆ ಅಣ್ಣ. ಯೂನಿಫಾರ್ಮ್ ಇದ್ರೆ ಏನಾಗ್ತದ್ರಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯೂನಿಫಾರ್ಮ್ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತೈತಿ, ಇದು ಜಸ್ಟ್ ರೊಟೇಟ್ ಆಗ್ತೈತಿ, ಇದು ರೊಟೇಟ್ ಆಗ್ತದೆ. ಸೊ ಫಾರ್ ಯೂನಿಫಾರ್ಮ್ ಫೀಲ್ಡ್ ಓನ್ಲಿ see electric field will be uniform. If the net force acting on net linear force act ಆಗತ್ತಿದ್ದಿಲ್ಲ, net linear force act ಆಗತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಡೈಪೋಲ್ ಏನಾಗುತ್ತೆ, ಜಸ್ಟ್ ಈ ತರ ಒಂದು ಡೈಪೋಲ್ ಅದ ಅಂತಂದ್ರೆ ಈ ಫೋರ್ಸ್ ಈ ಕಡೆ ಆಕ್ಟ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಫೋರ್ಸ್ ಈ ಕಡೆ ಆಗ್ತದೆ, ಜಸ್ಟ್ ಇದು ರೊಟೇಟ್ ಆಗ್ತದೆ. there is no net force, no linear force, no linear force. ಅವಾಗ ಏನಂತ ಕರಿಬಹುದು, ಯಾವಾಗ ಇದು ಹಂಗೆ ಆಗ್ತದಪ್ಪ ಅಂದ್ರೆ ಇದ್ಮೇಲೆ ಆಕ್ಟ್ ಆಗುವಂತ ಫೀಲ್ಡ್ ಏನಿರ್ಬೇಕು, ಯೂನಿಫಾರ್ಮ್ ಆಗಿರ್ಬೇಕು. ದಿಸ್ ಈ ಶುಡ್ ಬಿ ಯೂನಿಫಾರ್ಮ್, ಈ ಶುಡ್ ಬಿ ಯೂನಿಫಾರ್ಮ್. ಓಕೆ. ಅಕಸ್ಮಾತ್ ಇದ ಅಪ್ಲೈ ಮಾಡಿದ ಫೀಲ್ಡ್ ಯೂನಿಫಾರ್ಮ್ ಇರಲಿಲ್ಲ ಅಂತಂದ್ರೆ, ಸೊ ಇಫ್ F net is equal to not 0, if F net is not equal to 0, ನಾವು ಏನಂತ ಬರಿತೀವಿ, not equal to 0 ಇದ್ರೆ this F net is given by gradient of P vector dot E vector, because we write force is equal to ಏನಂತ ಬರಿತೀವಿ, negative potential energy gradient. Therefore U ಅನ್ನ ಬ್ಯಾಕ್ ತಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೀನಿ, that is going to get gradient of P vector dot E vector. So if net force equal to 0 ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಐತೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಹೆಂಗಿರ್ಬೋದು, ಸೊ ಇಲ್ಲಿ ಹಿಂಗ, ಸೊ ನನ್ನ ಮುಂದೆ ಈ ತರ ಸೊ ಮೀನ್ಸ್ ಕ್ರಾಸ್ ಏನಾಗಂಗಿಲ್ಲ, ಬಟ್ ಯೂನಿಫಾರ್ಮ್ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಆಗಿರ್ತೈತಿ. ಸೊ ಲೈಕ್ ದಿಸ್ ತಗೋರಿ, ಸೊ ಲೈಕ್ ದಿಸ್. ಸೊ ಈ ತರ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಆಗಿತ್ತು, ಈ ಡೈಪೋಲ್ ಇಲ್ಲದ ಡೈಪೋಲ್ ಅನ್ನ ಇದ್ರೊಳಗೆ ಬಿಟ್ಟೆ ಅಂತಂದ್ರೆ ನೋಡಿ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಜಾಸ್ತಿ ಇದೆ. ಯಾಕಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಲ್ಲಿ ಸಮೀಪ ಇರ್ತಾವ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಜಾಸ್ತಿ ಇರ್ತೈತಿ, ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕಡಿಮೆ ಇರ್ತೈತಿ. ಸೊ ಇಲ್ಲಿ ಫೋರ್ಸ್ ದಿಸ್ ಎಫ್ ಒನ್ ಅಂಡ್ ಎಫ್ ಟು ತೋದ್ರೆ ಎಫ್1 ಇಸ್ ಲೆಸ್ ದನ್ ಎಫ್2 ಆಗ್ತೈತಿ. ಸೊ ಅನ್ಇಕ್ವಲ್ ಫೋರ್ಸ್ ಆಗ್ತಾ ಹೋಗೋದ್ರಿಂದ ರೊಟೇಷನ್ ಅರ್ಥ ಆಗಂಗಿಲ್ಲ, ಒಂದ್ ಕಡೆ ಮೂಮೆಂಟು ಮಾಡ್ತೈತಿ, ಮುಂದೆ ಫಾರ್ವರ್ಡ್ ಆಗಿ ಮೂಮೆಂಟು ಮಾಡ್ತೈತಿ. Right? Therefore, it is going to express the total net force. Therefore, there this E is defined as E is non-uniform. Non-uniform. Okay. So electric field non-uniform ಆಗಿತ್ತು, ಯೂನಿಫಾರ್ಮ್ ಆಗಿರ್ಲಿಲ್ಲ ಅಂತಂದ್ರೆ so ಡೈಪೋಲ್ ಏನ್ ಮಾಡುತ್ತೆ, ನೆಟ್ ಫೋರ್ಸ್ ಅನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತದೆ. ಓಕೆ, this is what the force, energy and torque experienced by one electric field and magnet, electric potential and potential due to the dipole. Is that clear? And see, even we are going to expand this into multiple dipoles also. Multipole dipoles. Multipoles. What do I mean by this multipole? So here we generally call the term as monopole. Monopole means single charge. We call the term as, for a single charge we call this one as monopole. The dipole means two charges. Dipole means two charges. Two charges. Okay. So here see, monopole, dipole, similarly we define quadrupole also. Similarly we define quadrupole moment also. So that is defined here. The quadrupole moment is given by quadrupole ಅಂದ್ರೆ ಏನು? It is quadrupole. Quadrupole means totally 4 charges. Similarly we define octupole. Octupole for 8 charges. Okay. Generally ನಾವು multiples ಗಳು define ಮಾಡಬೇಕಾದ್ರೆ, multipoles ಗಳು define ಮಾಡಬೇಕಾದ್ರೆ, so we call, there is a rule, ಒಂದು ಕಂಡೀಷನ್ ಅದು, monopole ಒಂದು ಕಂಡೀಷನ್, monopole should satisfy this equation. monopole ಏನಂತ ಬರೀತೀವಿ ಅಂದ್ರೆ summation over qn, summation over qn ಏನ್ ಬರ್ತದ ನೋಡ್ಕೊಂಡು ಇದು ಮೊನೋಪೋಲ್ ಅದನೋ ಅಥವಾ ಡೈಪೋಲ್ ಅದನೋ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. This total q is equal to total net charge equal to 0 ಆಗಿತ್ತು ಅಂತ ತಿಳ್ಕೊಂಡು ಮೊನೋಪೋಲ್ ಆಬ್ಸೆಂಟ್ ಐತೆ ಅಂದಾಗ, ಇದು ಟೋಟಲ್ ಚಾರ್ಜ್ಗಳು ಸಮ್ ತಗೋರಿ, ಇದು ಸಮ್ ತಗೊಂಡಾಗ 0 ಆಗಿತ್ತು ಅಂದ್ರೆ ಸೊ ಮೊನೋಪೋಲ್ 0, ಮೊನೋಪೋಲ್ ಇಲ್ಲ ಅಂದಾಗ ಮೊನೋಪೋಲ್ doesn't exist, does not exist. ಸೊ ಇದು ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಇತ್ತು ಅಂದ್ರೆ ಮೊನೋಪೋಲ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗೈತೆ, ಮೊನೋಪೋಲ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿದೆ ಅನ್ನ. ಓಕೆ, ಈಗ ಡೈಪೋಲ್ ಐತೆ ಇಲ್ಲ ಅಂತ ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು? ಡೈಪೋಲ್ is summation over, if the summation over all the charges and their positions. Summation over qn with rn. Summation over n equal to 1 to capital N qn into rn. ಇದು ಕೂಡ ಹಿಂಗೆ, if it is equal to 0 ಆಗಿತ್ತು ಅಂದ್ರೆ ಡೈಪೋಲ್ ಆಬ್ಸೆಂಟ್ ಐತೆ ನನ್ನ ಸಿಸ್ಟಮ್. If it is equal to 0, dipole is absent. If not equal to 0 ಇತ್ತು ಅಂದ್ರೆ dipole is present. Dipole present ಅನ್ನೋದು. Okay. Similarly, ಈ ಮೊನೋಪೋಲ್ ಡೈಪೋಲ್ ಕೂಡ ಒಂದು ಮತ್ತೊಂದು ಮೊನೋಪೋಲ್, ಡೈಪೋಲ್, ಆಕ್ಟೋಪೋಲ್, ಕ್ವಾಡ್ರಪೋಲ್ ಒಂದು ಟೇಬಲ್ ಹಾಕಿಸ್ತೀನಿ, ಅದ್ರ ಮೇಲೆ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ ಯಾವುದು ಯಾವ ತರ. ಸೊ ಇಫ್ ಲೆಟ್ ಮಿ ಕಾಲ್ ದಿಸ್ ಇಸ್ ಅ ಪೋಲ್, ಇಲ್ಲಿ ಪೋಲ್ ಬರೀತೀನಿ, ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಬರೀತೀನಿ. Here one pole, here potential, and here I'll write electric field. Okay. Then see here, if I take the monopole, the pole is first I'll take this as ಮೋನೋಪೋಲ್ ಆಗಿತ್ತು. ಮೋನೋಪೋಲ್ ಇತ್ತು ಅಂದ್ರೆ ಕಂಡೀಷನ್ ಅದು ಚಾರ್ಜ್ ನೆಟ್ ಚಾರ್ಜ್ ಝೀರೋ ನಾನ್ ಝೀರೋ ಆಗಿರ್ಬೇಕು. ಪೊಟೆನ್ಷಿಯಲ್ ಒಳಗಡೆ ಮೊನೋಪೋಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಯಾವತ್ತು ಎದಕ್ಕೆ ಪ್ರಪೋರ್ಷನಲ್ ಇರ್ತೈತಿ ಅಂದ್ರೆ P is always proportional to 1/r. ಸಿಂಗಲ್ ಚಾರ್ಜ್ ಗಳಿಗೆ V/R ಇರ್ತೈತಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ ಸಿಂಗಲ್ ಚಾರ್ಜ್ ಗಳಿಗೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು 1/r² ಇರ್ತೈತಿ. ವಾಟ್ ಅಬೌಟ್ ಡೈಪೋಲ್ ನೋಡ್ರಿ. ಡೈಪೋಲ್ ಒಳಗಡೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ is directly proportional to 1/r². ಯಾಕಂದ್ರೆ ಮ್ಯಾಲ್ ಚೆಕ್ ಮಾಡ್ಬೋದು ನೋಡಿ. Potential due to the dipole is V is inversely proportional to 1/r². But electric field ಏನದ? Electric field is directly proportional to 1/r³ here. Then similarly quadrupole. Quadrupole ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ? Quadrupole ಒಳಗಡೆ this potential is directly proportional to 1/r³. Where in case of electric field is directly proportional to 1/r⁴. And similarly in case of octopole, we define that potential is directly proportional to 1/r⁴. Electric field is directly proportional to 1/r⁵. Quite a question. It's a network questions. Remember that monopole is going to have the potential as 1/r. ಆ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನು ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಟ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ತಾನ ಬರ್ತೈತಿ. ಪೊಟೆನ್ಷಿಯಲ್ ಯಾವತ್ತು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾವತ್ತು ಇರ್ತೈತಿ ಅದಕ್ಕಿಂತ ಒಂದು ಜಾಸ್ತಿ ಇರ್ತೈತಿ ಅದ್ರ ಪವರ್. 1/r the r², 1/r² r⁴, r⁴3, r⁴4, r⁴5 like that. So only remember this monopole ko 1/r, this 1/r², 1/r³, 1/r⁴. Octopole 1/r⁴, quadrupole 1/r³. Then dipole 1/r², monopole 1/r. So like that we define. Okay. Similarly, ಈಗ ಕ್ವಶನ್ ಕೇಳ್ತಾನೆ, ಯಾವ ತರ ಕ್ವಶನ್ ಕೇಳ್ತಾನೆ ಅಂತಂದ್ರೆ ಈಗ ಒಂದು ಚಾರ್ಜ್ ಕೊಟ್ಟಾನೆ, ಇನ್ನ ಬರುವಂತ ಪೊಟೆನ್ಷಿಯಲ್ ಆರ್ ಮೇಲೆ ಹೆಂಗ್ ಡಿಪೆಂಡ್ ಅದ ಅಂತ ಕ್ವಶನ್ ಕೇಳ. ಒಂದ್ಸತಿ ಪ್ರಿವಿಯಸ್ ಇಯರ್ ನೆಟ್ ಕ್ವಶನ್ ಅದ ನೋಡಿ. ಸೊ ಐ ವಿಲ್ rewrite that question and read it. Question is four charges, 2 plus q charge, 2 plus q charges and 2 plus q charges and 2 minus q charges. Okay, are kept fixed at the four distances at 4 distances as shown in the figure. At 4 vertices of a square of a side A as shown like this. Let us take a square theory. Square ಗೆ ಮಾಡ್ರಿ, ಇದು ಪ್ಲಸ್ ಕ್ಯೂ, ಇಲ್ಲಿ ಇದು ಮೈನಸ್ ಕ್ಯೂ, ಇದು ಪ್ಲಸ್ ಕ್ಯೂ, ಇದು ಮೈನಸ್ ಕ್ಯೂ. ಸೊ ಈ ಸಪರೇಷನ್ ಏನದ ಇ ಅದು. ಸೊ ಇದ್ರದ ಪೊಟೆನ್ಷಿಯಲ್ ಅಟ್ ವಿಚ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆರ್, ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಒಳಗಡೆ ಪೊಟೆನ್ಷಿಯಲ್ ಎಷ್ಟಿದೆ ಕೇಳ್ತೀನಿ. ಆರ್ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಆ ಪ್ಲೇನ್ಗೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅದ. ಸೊ at the point P, which is at the distance r is greater than small a, the potential is proportional to first option is, you got the question, read it properly, then I'll give the option, tell me the answer. First option A, 1/r, Second option 1 by r square. Then third option 1 by r cube. Then fourth option 1 by r power 4. Please tell me. What is the answer for this? Note, system ಏನದ quadruple ಅದ. System ಏನದ quadruple ಅದ. 4 charges ಅದಾವ. 1, 2, 3, 4. Therefore, figure shows quadruple moment. So, system ಏನದ quadruple ಅದ. Quadruple ಇತ್ತಂದ್ರೆ ಏನ್ ಬರ್ತೈತ್ರಿ? V is directly proportional 1 by r power. Octuple ಇದ್ರೆ r power 4 ಬರ್ತೈತಿ. Quadruple ಇದ್ರೆ r power 3. This is the answer for this. Doctor? So, ಈ ತರ ನಾವು potential calculate ಮಾಡ್ಕೊತ ಹೋಗ್ಬೇಕು. Then ಇನ್ನೊಂದು ಕ್ವೆಶ್ಚನ್ ಕೊಡ್ತೀನಿ ನೋಡ್ರಿ, ಇದು ಸಾಲ್ವ್ ಮಾಡ್ರಿ, ಬಿಟ್ಬಿಡ್ತೀನಿ. One second. So let the 4 point charges q minus q by 2 and q minus q by 2 are placed at the vertices of the square of the side A. Let the another charge minus q be placed at the center of the square. Center of the square ಒಳಗಡೆ minus charge ಇಟ್ಟಾಗ let V be the electrostatic potential at the point P, the distance r greater than a from the center of the square. Then the ratio of V by 2r2. So V of 2r2, V of r the ratio ಕೇಳಾತೀನಿ. ಏನೇನು ಬರ್ತದೆ ಫಸ್ಟ್ ಇದು ಯಾವ ತರ ಸಿಸ್ಟಮ್ ಅದ ನೋಡ್ನು. ಆ ಸಿಸ್ಟಮ್ ನೋಡಿ ವೆದರ್ ಇಸ್ ಆಕ್ಟೋಪೋಲ್ ಅದನೋ, ಕ್ವಾಡ್ರಪೋಲ್ ಅದನೋ, ಅಥವಾ ಮೊನೋಪೋಲ್ ಅದನೋ, ಡೈಪೋಲ್ ಅದನೋ ನೋಡ್ಕೊಂಡ ಸೊ ಅದನ್ನ ವಿ ಅನ್ನು ಡಿಫೈನ್ ಮಾಡಿ. ಇಫ್ ವಿ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆರ್ ಪವರ್ ಎಷ್ಟು ಬರ್ತದೆ ನೋಡು, ದೆನ್ ಅದು ರೇಷಿಯೋ ತೆಗೆದು ಡೈರೆಕ್ಟ್ ಆನ್ಸರ್ ಬರ್ತದೆ. ಬಟ್ ಟೆಲ್ ಮಿ ವೆದರ್ ಇಟ್ ಇಸ್ ಅ ಮೊನೋಪೋಲ್, ಡೈಪೋಲ್ ಆರ್ ಕ್ವಾಡ್ರಪೋಲ್. ಚೆಕ್ ಮಾಡ್ರಿ. ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿ. ಮೊನೋಪೋಲ್ ಆದ್ರೆ ಸಮೇಶನ್ ಓವರ್ ಕ್ಯೂ ಏನ್ ಬರ್ತದೆ ನೋಡಿ. ಎಷ್ಟು ಚಾರ್ಜಸ್ ಅದಾವಿಲ್ಲ? 5 ಚಾರ್ಜ್ ಅದಾವ. ಒಂದು ಮೈನಸ್ ಕ್ಯೂ ಬೈ ಚಾರ್ಜ್ ತಗೋರಿ, ಮೈನಸ್ ಕ್ಯೂ ಬೈ 2 plus 1 q. Another is minus q by 2, then plus q. Correct? Another one is that minus q? Is that total minus q? Is that equal to 0 ಬರ್ತೈತಿ? ಏನು ಬರ್ತೈತಿ? No. So it ಚಾರ್ಜ್ ಅದ. ಇದು q ಅನ್ನೋದು ಏನಿದೆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಐತಿ. ದಿಸ್ q is a ಟೆಸ್ಟ್ ಚಾರ್ಜ್. ಈ ಚಾರ್ಜ್ ಬಿಡಲ್ಲ, ಈ ಚಾರ್ಜ್ ಬಿಡಬೇಕು. ಈಗ ಸಿಸ್ಟಮ್ ಇರೋದೇನು ಓನ್ಲಿ ಇದನ್ನಷ್ಟ ಅದು. ಸೊ ಅದು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅದ. ಆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಬಿಟ್ರೆ ಇದೇನು ಈಕ್ವಲ್ ಟು 0 ಆಗ್ತೈತಿ. ಅಂದ್ರೆ ಮೊನೋಪೋಲ್ ಇಲ್ಲ. ಡೈಪೋಲ್ ನೋಡ್ರಿ, ಡೈಪೋಲ್ ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ? ಸಮೇಶನ್ ಓವರ್ ಕ್ಯೂ ಎನ್ ಇಂಟು ಆರ್ ಎನ್. ಅದ್ರ ಲೊಕೇಶನ್ಸ್ ನೋಡ್ಬೇಕು, ಅದು ಚಾರ್ಜ್ ನೋಡ್ಬೇಕು. ನೋಡ್ಕೊಂಡ್ರೆ ಹೆಂಗೆ ಬರೀತೀವಿ? ಒಂದು ಪ್ಲಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ತಗೋರಿ. ಒಂದು ಪ್ಲಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಎಲ್ಲೈತಿ. ಈ ಪ್ಲಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಲೊಕೇಶನ್ ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡೋರು? ದಟ್ ಇಸ್ ಎ ಬೈ 2, ದೆನ್ ಎ ಬೈ 2. ಇದು ಮೈನಸ್ ಎ ಬೈ 2 ಪ್ಲಸ್ ಎ ಬೈ 2 ಹಿಂಗೆ ಬರ್ಕೋತ ಹೋದ್ರ ಮೊನೋಪೋಲ್ ಕ್ಯೂ ಬರಂಗಿಲ್ಲ. ಯಾಕಂದ್ರೆ ಇದು ಚಾರ್ಜ್ ಇಟ್ಸ್ ಅ ಟೆಸ್ಟ್ ಚಾರ್ಜ್. ಪ್ಲಸ್ ಕ್ಯೂ ಇಸ್ ಅನದರ್ ಚಾರ್ಜ್. ಬರ್ತದ
ಮೈನಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಕ್ಯೂ ಒಂದು ಕ್ಯಾನ್ಸಲ್ ಆಗಿದ್ರೆ ಒಂದು ಕ್ಯೂ ಉಳಿತದೆ.
minus q by 2, q by 2 plus q by 2, sorry, plus q by 2. Okay, ಎರಡು
ಮೈನಸ್ ಕ್ಯೂ ಬೈ 2.
ಓಕೆ
2 ಮೈನಸ್ ಕ್ಯೂ ಬೈ 2, 1 ಪ್ಲಸ್ ಕ್ಯೂ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ, ಒಂದು
ಕ್ಯೂ ಉಳಿತದೆ. ಬಟ್ ಇಷ್ಟು ಬಿ 0 ಆಗ್ಬೇಕಲ್ಲ, ಯಾಕಂದ್ರೆ ಅದು ಇದನ್ನದ ಕ್ವಾಡ್ರಪೋಲ್ ಮೂಮೆಂಟ್ ಅದು ನೋಡ್ರಿ. 2q ಆಯ್ತು. 2q ತಗೊಂಡ ಒಂದು ಮೈನಸ್ q ಬಟ್ಟು ಒಂದು ಪ್ಲಸ್ q ಬಟ್ಟು ದೆನ್ ಮತ್ತೆ ಅಕಸ್ಮಾತ್ ಇನ್ನೊಂದು ಸೆಂಟರ್ದಾಗಿಂದ ಹಾಕಿದ್ರು ಕೂಡ ಜೀರೋ ಆಗಂಗಿಲ್ಲ. ಸೆಂಟರ್ದಾಗಿಂದ ಚಾರ್ಜ್ ಹಾಕಿದ್ರು ಕೂಡ ಓ ಸಾರಿ ಸಿ ದಿಸ್ ಇಸ್ ಮೈನಸ್ q ಬಟ್ಟು ಮೈನಸ್ q ಬಟ್ಟು ಎರಡು ಅದಾವ. ಒಂದು ಪ್ಲಸ್ ಚಾರ್ಜ್ ಆಗಲ್ಲ, ಒಂದು ಮೈನಸ್ q ಆಗ್ತೈತಿ. ಇದು ಮೈನಸ್ q ಬಟ್ಟು ಅದ, ಇದು ಮೈನಸ್ q ಬಟ್ಟು ಅದ. ದಿಸ್ ಇಸ್ ಮೈನಸ್ q ಬಟ್ಟು ಪ್ಲಸ್ q ಬಟ್ಟು, ದಿಸ್ ಇಸ್ ಟೋಟಲ್ q. ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಬಟ್ q ಉಳಿತು. ಇದು ಟೋಟಲ್ ಜೀರೋ ಆಗ್ಬೇಕಾದ್ರೆ ಇದನ್ನ ತೊಗೊಂಡ ನಂಗೆ ಆಯ್ತು. ಹಂಗಿದ್ರೆ ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ಯಾನ ತೊಗೊಂಡ ಒಂದು ಸೆಕೆಂಡ್. ತಗೊಂಡ ನಾವು ಐದು ಚಾರ್ಜ್ ತಗೊಂಡ ಇದ್ರೆ ಒಂದು ಮೈನಸ್ q ಬಟ್ಟು, ಒಂದು ಪ್ಲಸ್ q ಬಟ್ಟು, ಒಂದು ಮೈನಸ್ q ಬಟ್ಟು, ಪ್ಲಸ್ q ಬಟ್ಟು, ದೆನ್ ಒಂದು ಪ್ಲಸ್ q, ಇನ್ನೊಂದು ಮೈನಸ್ q ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ತಗೊಂಡ 5 ಚಾರ್ಜ್ ತಗೋಬೇಕು. ಮೀನ್ಸ್ ಆ ಸಿಸ್ಟಮ್ದಾಗ ಒಟ್ಟು ಚಾರ್ಜ್ ತಗೋಬೇಕು ಅನ್ನಂಗೈತೆ. ಅಂದ್ರೆ ಹೋಲ್ ಸಿಸ್ಟಮ್ ಅಟೆಂಡ್ ಮಾಡತ್ತೆ ಬಿಕಾಸ್ ಇಟ್ ಚಾರ್ಜ್ ಅಷ್ಟೈತಿಲ್ಲ. 5 ಚಾರ್ಜ್ ತಗೋರಿ. 5 ಚಾರ್ಜ್ ತಗೊಂಡಾಗ ಅಟ್ಟ ಜೀರೋ ಬರ್ತೈತಿಲ್ಲ, ಅದು ಬರೋಂಗಿಲ್ಲ, ಹೌದಿಲ್ಲ? ಸೊ ಹಿ ಹ್ಯಾಸ್ ಟೇಕನ್ ಇದು ಕೂಡ ತಗೊಂಡ. ಸೊ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಇತ್ತು ಟೋಟಲ್ ಸಿಸ್ಟಮ್ ತಗೋಬೇಕು ಹಂಗಿದ್ರೆ. ಸೊ ನೀಡ್ ಟು ಟೇಕ್ ಸಿಸ್ಟಮ್ ನೇಮ್. ಸೊ ಸಿಸ್ಟಮ್ ತಗೊಂಡ್ರೆ ಕರೆಕ್ಟ್. ದೆನ್ ಇದ್ರ ನೋಡ್ರಿ ಡೈಪೋಲ್ದ Qn Rn ತಗೊಂಡಿ ಅಂದ್ರೆ ಒಂದು ಪ್ಲಸ್ Q ತಗೊಂಡಿ ಅಂದ್ರೆ ಇದು a/2 at a/2 I cap plus a/2 J cap. ದೆನ್ ಇನ್ನೊಂದು ಮೈನಸ್ Q/2 ಟೈಮ್ಸ್ ಆಫ್ ಮೈನಸ್ a/2 I cap ಪ್ಲಸ್ a/2 J cap. ಇನ್ನೊಂದು ಎರಡು ಚಾರ್ಜ್ ಅದು, ಮೂರನೇ ಚಾರ್ಜ್ ಇದು Q plus Q at this is plus Q, this will be plus Q plus Q. ಇದ್ರದ್ದು ಲೊಕೇಶನ್ ಬರ್ತದ್ರಿ plus Q. One is minus a/2 I cap minus a/2 J cap. ಇನ್ನೊಂದು ಯಾವುದು ಮೈನಸ್ ಆಫ್ Q/2 ಟೈಮ್ಸ್ ಇನ್ನೊಂದು ಲೊಕೇಶನ್ ಪ್ಲಸ್ ಟೈಮ್ಸ್ ಆಫ್ a/2 I cap ಬರ್ತೈತಿ, ಮೈನಸ್ ಟೈಮ್ಸ್ ಆಫ್ a/2 J cap ಬರ್ತೈತಿ. ಇನ್ನೊಂದು ಫಿಫ್ತ್ ಚಾರ್ಜ್ ಒಂದು ಐತಿಲ್ಲ, ಫಿಫ್ತ್ ಚಾರ್ಜ್ ಎಲ್ಲಿ ಬರ್ತೈತಿ? ಫಿಫ್ತ್ ಚಾರ್ಜ್ ಇಂಟು ಎನಿಮಿ ವರ್ಜಿನ್ ಆಗದ. ಸೊ ದಿಟ್ ಇಸ್ ಮೈನಸ್ Q ಇಂಟು 0 ಪ್ಲಸ್ 0. ಟೋಟಲ್ ಏನು ಬರ್ತೈತಿ ನೋಡ್ರಿ, ಎಲ್ಲ ಒಟ್ಟು ಸಮ್ ಮಾಡಿದ್ರೆ ಡೈಪೋಲ್ ಚೆಕ್ ಮಾಡೋದು. ಇದು ಒಟ್ಟು ಸಿಸ್ಟಮ್ದಾಗಿನ ಚಾರ್ಜಸ್ ತಗೊಂಡು ನೋಡ್ರಿ, ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. ಇಲ್ಲಿ ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. ದೇರ್ಫೋರ್ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಈಕ್ವಲ್ ಟು 0. ಅಂದ್ರೆ ಮೊನೋಪೋಲ್ ಇಲ್ಲ, ಡೈಪೋಲ್ ಇಲ್ಲ, ಕ್ವಾಡ್ರಪೋಲ್ ಅಂತಂದ್ರೆ ಮೀನಿಂಗ್ ಅಂದ್ರೆ ಕ್ವಾಡ್ರಪೋಲ್ ಏನಾಗ್ಬೋದು ಹೇಳ್ರಿ? Q ಕ್ವಾಡ್ರಪೋಲ್ ಅದು ಅಕಸ್ಮಾತ್ ಚೆಕ್ ಮಾಡಕ್ ಹೋದ್ರೆ Q ಕ್ವಾಡ್ರಪೋಲ್ ನಾನ್ ಜೀರೋ ಬರ್ತದೆ ಫಿಕ್ಸ್, ಹೌದಿಲ್ಲ? ಈಗ ಆಕ್ಟಾಪೋಲ್ ಬರ್ಬೇಕಾದ್ರೆ ಚಾರ್ಜ್ಗಳು ಭಾಳ ಬೇಕು. ಆಕ್ಟಾಪೋಲ್ ಬರ್ಬೇಕಾದ್ರೆ ಚಾರ್ಜ್ಗಳು ಭಾಳ ಬೇಕು. ಯಾಕಂದ್ರೆ 8 ಚಾರ್ಜ್ ಬೇಕಾಗ್ತದೆ. 8 ಚಾರ್ಜ್ ಅಂತೂ ಇಲ್ಲ, ಆಕ್ಟಾಪೋಲ್ ಅಂತ ಆಬ್ಸೆಂಟ್ ಪ್ರೆಸೆಂಟ್ ಇದ್ರೆ ಯಾವ್ದು ಇರ್ಬೋದು ಇಲ್ಲಿ? ಇಟ್ ಇಸ್ Q quadrupole is non-zero, so therefore it is present. If present ಇದರ potential ಹೆಂಗ್ ಬರೀತೀರಿ ನೀವು? Potential V is directly proportional to R power 3. Therefore V at 2R divided by V of R ಕೇಳತ್ತಾನ. V of 2R divided by V of R. What is the value this one? This is 1 by 2R whole cube and into 1 divided by R cube. Therefore the answer is 1 by 8. Is that correct? Another already option. Right? Is that clear? This is what ಹಿಂಗೆ ಡೈಪೋಲ್ಸ್ ಕ್ವಾಡ್ರಪೋಲ್ ಯಾವ ಪೋಲ್ಸ್ ಅದ ಚೆಕ್ ಮಾಡಬಹುದು. ಇನ್ನೊಂದು ಅದ್ರ ಪೊಟೆನ್ಶಿಯಲ್ ಅಂಡ್ ರೆಸಲ್ಯೂಷನ್ ಕೇಳ್ತದೆ. ಇದು CSR ನೆಟ್ ಮತ್ತು ಸೆಟ್ ಒಳಗೆ ಕೇಳೋದು. ಸೊ ಈವ್ನಿಂಗ್ ಕ್ಲಾಸ್ ಒಳಗೆ I'll start with the polarization, then we'll go to the capacitance, then ಹಂಗೆ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಕೊತ. Okay.